Inspirational personalities have achieved more than most. But we forget they are normal people, just like us. So we want to learn about the way they think, to understand how they have achieved greatness.
So hello and welcome to another episode of Cambridge Encounters. Today we're very excited to be welcoming Jennifer Doudna. So we thought we'd start the interview by asking you to tell us a bit about yourself, maybe where you grew up and your journey to becoming a scientist.
Well, thank you, Emily. It's a great pleasure to be here with you and Julius. I grew up in Hawaii. It's the 50th state in America, and it is out in the middle of the Pacific Ocean. I grew up on the big island of Hawaii, called Hawaii, and a small town called Hilo. It's not a place that you think of, probably, when you think of Hawaii. It's not necessarily warm and sunny all the time. It's quite rainy, very beautiful. And nobody in my family was a scientist. So I got interested in science because I was fascinated by the natural world on that wonderful island environment.
Wow, and that's amazing. So did that take you then on to studying a biological-based degree for your undergrad?
Actually, I majored in chemistry in my undergraduate. I got excited about chemistry in high school, and I realized that what I really wanted to do was to understand the chemistry of life. And so I went into biochemistry, but my undergraduate college had the major was chemistry. So I had a chemistry degree, but with a focus on biochemistry.
Nice, and is that what took you into your PhD studying?
Yes,
Yeah.
I did. I went on in my PhD in biological chemistry.
Very nice. And then could you tell us a bit more about your process of following your PhD, how you got into what you're doing today?
Well, after my PhD, I went to the University of Colorado. In our field, we typically do a postdoctoral period of training, and that's what I did at Colorado. And I was working there on trying to see the structures of molecules we were working on. And so I went there to do that type of work, and it was quite new in the field at the time. So there was a lot of risk involved, but it was fun, it was exciting, it was terribly scary. I thought maybe nothing will work out, but actually it did. And so I ended up taking a position as a faculty member at Yale University on the East Coast of the US when I started my independent research career. That was in 1994. And then I loved Yale. I thought I would probably stay there forever, but a few years later, 8 years later, I had been promoted. I had been tenured at Yale, but I got a job offer at the University of California. And I was getting married at the time, and my spouse got an offer there as well. So we both picked up our things and moved to California.
Wow. And that seems like quite a big decision. Did you feel like that was maybe a risk that you were taking, or did it feel like the right thing to be doing for your science as well as your personal life?
Both. I knew it was a bit of a risk because you get settled one place and things are going well, and then you pick everything up and move, and you don't really know what will happen. But in my heart, I felt it was the right thing to do, both for my professional career as well as for our personal life, because my family was still in Hawaii at the time. And we had gotten married in the year 2000, and we actually moved in 2002, and I was pregnant with our son. And so we felt that it would be very nice to be a little bit closer to our families. My husband is from Colorado, so out west. And we also, frankly, we both of us loved the fact that the University of California is a public university. So it's a little bit maybe different than the UK system. We have a number of private colleges. Yale is one, and many that are very, very good. But we also have public universities, like the University of California, which is one of the top universities. And it is a school that opens its doors to people from all over the world, and the cost is at a level that most students can afford it, and if they can't, we find ways to pay for their education. So we love the fact that we would be working with people from everywhere, and they were all there simply because they wanted to learn and study.
Would you have expected your career to look the way that it has when you were starting out, or were there any twists and turns that you weren't expecting?
Oh, I could have never expected my career to turn out the way that it did. No, I loved science, and I wanted to pursue it with people I liked working with, and so I've always kind of valued the people side of our work. I also got fascinated early on with evolution, the process of evolution, and trying to understand why is life the way it is? Why didn't it evolve in some different way? And so that's always been kind of a theme running through our research. But I've pursued projects I felt were interesting to me and that would, I hoped, give us principles, lead to insights about these very fundamental principles of evolutionary biology in the end, from a chemical perspective. And the path that I took I don't think it could have been predicted really, because it ended up being quite serendipitous that I met people who we collaborated with, including with Emmanuel Charpentier, and the scientists in our laboratories that ended up doing the work on genome editing, CRISPR research. And it all came together in ways that were quite exciting, but certainly unexpected at the time. Yeah.
So you mentioned you were quite interested, fascinated by the science, and then you became a scientist as well. But as we briefly mentioned, you also started to get involved with individual companies. Did you find this was a difficult transition?
Well, let's start with, when I was a student, a graduate student, it was frowned upon to work in companies. This was back in the late 1980s, and I was a student at Harvard. And at Harvard, certainly, many of the professors, including the person I was working with, Jack Szostak, wonderful mentor, by the way, wonderful, just loved being in his laboratory. But he and others at the time really felt that if you were serious about science, that you should become an academic scientist. That was the kind of the thinking. And nonetheless, I was in Cambridge, Massachusetts, and there were many biotech, well, not many, but there were some, biotech companies that were starting up at the time. And I was curious about them, very curious. And I went on a tour of Regeneron, if you've heard of it. It's a company that's still going these days. And it was quite interesting to see, how the labs were set up and how it was structured more in teams, teams of scientists working on projects rather than individual projects as in, typical academic labs. Nonetheless, I ended up staying, the course of academia at the time because it felt like the right way for me to pursue the science I wanted to work on. However, later, much later, when we had started to work on CRISPR biology, I had a woman, a female graduate student in my lab, Rachel Horowitz, who was clearly very interested in business, although she was also a fabulous researcher. And so with CRISPR, we realized pretty early on that it was going to be a very useful tool. We didn't know for what in the early days. It was actually before we had started working on the genome editing part of it. But she and I started a company called Caribou Biosciences. That was back in 2011. So that was my very first experience starting a company. And today, that company is a publicly traded company, and Rachel is the president and CEO of it. So it's really been great. And there have been some other companies, maybe we'll get to that. But I would just say that in my experience, there are times when a discovery in science really needs the kind of resources and teams that you can build uniquely, I would say, in companies to take a discovery and turn it into a practical application. And that's really where it makes sense, in my view, to have a company get started.
So do you think nowadays, with the biotech sector growing immensely, it is very important for young or early career scientists to at least have an idea of the biotech sector?
Well, you can probably imagine my answer. I certainly think it's very important to understand both sides. And we try to do that in our educational program now at the University of California, Berkeley. We offer students opportunities to interact with scientists from companies. We open the door for them to have internships at companies if they want to. One of my students was at a company last summer, for example, and really enjoyed it. It was very interesting, very different. I think she likes both, and she can now decide which is the right environment when she finishes her PhD. So I definitely think it's very important that we provide opportunities across the spectrum of academics and companies for students, because I think you can do wonderful research in both settings, and you just have to decide, where your interest coincides with the group that you're going to work with.
How did you find the differences between leading a lab and leading a company? And were there any skills that you felt like were very similar between them both, or like anything that you struggled with because they were quite different?
To be clear, I've never led a company. And in fact, I tell Rachel Horowitz that I probably couldn't do her job. It's a hard job. I'm very proud of her successes. But my sense is that there's some interesting similarities, but also differences. So the similarities, I would say, is that, you know, if you're running an academic lab, or you're running a company or a research group in a company, either way, you have to be good with people. You're right. You have to be able to lead people, get them motivated, excited, see what they're good at doing, and match them up with the right, you know, projects that kind of match their skills and interests. I think that's a lot of fun. And when you get it right, obviously magic happens. You know, I love doing that in my academic lab, but I think it's important to do that in companies as well. I think where things are a bit different in companies compared to academia is that, you know, when you're in an academic setting, you really don't have to think about things like freedom to operate. Have you ever heard that terminology? Yeah, right. It means, you know, if you're at a company, you have to ask, do I have the legal right to work on this thing? Because, you know, do I have access to patents and licensing to do certain kinds of work? Whereas in academic settings, you know, for the most part, we never think about that, right? We just, you know, we do whatever we want to do, and we don't have to worry about that. So I think that's an important distinction that happens when you move to a company, is you suddenly have to crank that into your thinking.
So aside from you being a successful scientist and also successfully establishing individual companies, you're a very public figure. How does that make you feel? I can assume you said you never planned how your career is going to work out, or you didn't expect it to work out in that way. So how do you feel like being kind of an advocate for using CRISPR-Cas9 in an ethical way? And yeah, maybe just tell us a bit about that.
Well, I could have never predicted my career going in this direction. I think that, you know, it's very important for scientists to be thinking about the impact of their work outside of their own laboratories and their own communities of other scientists. And with CRISPR, clearly from the very early stages of the project, it was clear that this could have very powerful impacts on human health, on the environment, agriculture, and also it came along with a lot of risk. So I had to get over my discomfort with, you know, getting out publicly and talking about those risks versus benefits, because I felt that it was critical to, you know, that people who really knew the science would be involved in that conversation. So I founded, you mentioned the Innovative Genomics Institute in your introduction. I founded that institute. It's a nonprofit academic institute back in 2015 because we could see where the technology was headed, and also that there were some important issues that needed to be dealt with regarding CRISPR technology. And so I've been involved in that more public part of CRISPR ever since then. How do I feel about it? Well, it's always a little bit scary because I know that I'm not an expert in certain aspects of the technology that are, you know, being questioned now. For example, human embryo editing and making changes to ourselves as human beings that could be passed on to future generations. And I've had to learn from other scientists that are experts in that area, as well as, you know, people who really understand bioethics, which is not a field I trained in. But it's been an incredible journey of, you know, just people coming together, working together, realizing that there's an extraordinary opportunity with this technology, but we need to be responsible. So I've been encouraged by the fact that people really around the world that I've met with are, you know, they want to work together on this issue.
So you mentioned mainly that through your Innovative Genomics Institute and basically appearing in public, you said it's important to educate the scientists on it, and also, and maybe also, what about the public, where you have to talk to a lay audience?
Yeah, it's very important, and it is an important challenge as well, because as you know, you are both scientists as well, you know that when you get into your field, you start to speak with your colleagues using certain terminologies and phrases that most not non-scientists would not recognize. And so you have to learn to speak about your work in a way that people who are not trained in science can still understand at some level. So I think that's very important. I think that for me, I really I don't like to feel like I'm lecturing someone else about, what I think should be done. It's more about, I want to learn from them too. I want to invite a conversation to happen. There's things that I know and I'd like to share with them, but there are things that they know that I don't, and I want to hear their perspective. So at our institute, for example, we've had a number of workshops, and this is things that we do on an ongoing basis, where we invite in members of the community, people that are affected by genetic disease, for example, or farmers who might benefit from CRISPR in the future. And we have that kind of a conversation. We talk about the science and where it's going and help them understand that, but we also, and answer their questions, but we also ask them, what do you need? What are you looking for? What are you afraid of? What are your thoughts and hopes for the future? Because I think it's only by doing that kind of exchange that you can really build trust. And as you know, probably, trust in science and scientists has degraded over time. It's sad, it's really unfortunate. And I think we, as scientists, we have to work to build that back up. And part of it is us. We have to be willing to talk to people who are not scientists, and we have to be willing to hear what they have to say.
Do you feel there's a bit of pressure now on you, or maybe in generally, scientists to kind of make sure, as you said, because the kind of like trust in science has degraded over the past years?
I feel that I put that pressure on myself, though, in a way, right? There is, but it's coming internally. I feel a responsibility to do it. I would feel not right about myself if I were not doing that at some level, because of the, just the opportunities, but also the risk of the technology that, I was involved in developing. So I just feel that it's important to do it. I also respect that not everybody wants to do that. Many of my colleagues say, that I'm not comfortable, I don't want to do it, I want to just do my research, and I respect that. But I think at least for people that can get comfortable with it, it's important.
So obviously, you've achieved many things in your career. We were wondering, what is your biggest achievement in your opinion?
Oh, no question. My biggest achievement is the people I've trained that are off doing amazing work now. I'm so proud of them. There's so many people over the years. I've now been running my laboratory for almost 30 years. And so I look back and I look at all of the folks that have trained over the, kind of various lab generations in my lab. And many of them are tenured professors at institutions all over the world doing amazing work. But increasingly, many of them are also at companies, and they're either members of companies, or they are founders and leaders of companies, kind of all levels. I do have some of my trainees who are doing other things. I have a wonderful student, for example, who finished relatively recently, did amazing work in the lab, but decided that she wanted to go into patent law. So she's working at a law firm now, and we stay in touch, and she's just, super sharp, and I am excited to see what she'll do in the future. So it really gives me great joy to see what these folks are doing, and I'm proud that I could have had some kind of role in their training to then help them do the very best work in the future.
And is there anything that's maybe not in such a scientific sense that you're also very proud of?
Oh, my son. I'm very proud of my son, it's yeah, and again, I don't take a lot of credit here, a little credit, but but he's 21, he's finishing college in the States, he's at University of California, Berkeley, he's training to be an engineer, and he likes rockets and rocket engines. So he's got his own thing that he's very good at, and it's an area of science that I don't know much about, so I'm learning from him, and it's wonderful to see his ideas and his personality and his skills developing.
Does that motivate you as well when you see people in your lab going on to like bigger roles in either companies or maybe even law firms? Do you draw like motivation from it?
I do. Yeah, I absolutely do. Yeah, I'm fascinated. I find that this is something I've learned about myself as I've gotten older. I didn't really think about this when I was starting my career in science. I was just, at the time I was very focused on the science. I loved it. Loved doing stuff in the lab. But over time, I think as I've, kind of gone on in my career, what I found is that about myself, is that I really love people. I'm fascinated by how people do things, and what I love doing is, I meet a new person, say a new student that joins my laboratory. I like to learn about who they are and how they think and what they like to do, what they don't like, what they're really good at, and then, try to match them up with a project that will be, suited to them, and then also to help them think through where are they headed, what they want to do in the future. What are they going to be good at doing? And sometimes, you probably know, sometimes it's a hard conversation, right? Sometimes, right? People might initially be thinking they're headed in one direction, and then they get into graduate school and they realize, actually, this isn't me. I don't want to do this. I want to do something else, And so you have to kind of help them figure that out. And I think for me, that's my job really, is to help them figure that out. If I get that right, then I've done my job.
You said you were curiosity-driven at the beginning because you wanted to understand the science. Now you said you're also quite motivated by how your, let's say, students, which career path they take. Is there anything else which you kind of like, which drives you at the moment?
Well, I guess the third piece would be wanting CRISPR technology to have real-world impact. We're on the verge of a very exciting moment in the field because I think that we're about to see clinical approval of the first CRISPR therapy, both here in the UK and Europe, as well as in the United States. And this is a CRISPR therapy for sickle cell disease. It's a very well-known genetic disorder. It affects people that inherit 2 copies of a gene that gives rise to defective red blood cells. And with CRISPR, we can actually now provide a cure for this disease, not just a therapy, a chronic treatment, but a one and done cure for this disease. It's extraordinary. At the same time, we're not done in this. I feel like we're just at the very beginning because, first of all, there's many other genetic diseases. Secondly, the therapy right now requires hospitalization for the patient for a period of time, as well as it's very expensive. It's probably going to cost between $1 and $2 million US per patient, which means that the vast majority of people around the world that might benefit from this can't get access to it. So I'm really motivated by this because I think that there are ways that we can bring down the cost dramatically. So that's, again, a reason we founded the Institute, was to work on that problem together.
That's very admiring. But I can also imagine, is it overwhelming from time to time?
It is overwhelming. It's a big goal. How do you achieve it? I mean, it's hard. It's very hard. Will we get there? Not overnight, but in my experience, you certainly won't get there if you don't try and aim for it. And I think this is one of the luxuries we have in academia, for example, is that we can really, in America we say swing for the fences, right? It's like in baseball. In this setting, it really refers to the fact that we can aim for a goal that might be 10 years away, but we can go after it. If you're at a company, you've got investors and they've got goals and they want to make money and they don't want to wait 10 years to make money, right? They want to make money in 2 years or 3. So you might have, 2 or 3 years to get something done. So if you look at, most companies, they're setting their sights on goals, things that they can achieve relatively quickly, usually. Whereas, for something like this, I think it's going to take, it's going to take more scientific discovery and development, as well as figuring out new creative ways to price drugs. How do we work with companies, for example? I mean, we're very keenly interested in working with companies on this, but we want to work with them in a way that we can, have a little bit of leverage to set pricing and say, look, if you're going to work with us, we'd like to have a tiered pricing structure, for example, where we, charge what people can afford and no more.
Very interesting. You need kind of like several different players, scientists, the industry, potentially politics.
And regulators. Right? They play a key role as well.
Yeah. So this seems quite, as I said, an overwhelming or difficult task to achieve. Do you have a personality trait or character trait which makes you well equipped for this?
Stubborn.
Okay.
Very stubborn. I don't like, if people tell me, oh, that can't be done, I'm the type of person who will say, oh, that's the problem I want to go after.
Okay.
Right, so I like working on things that are hard and challenging. I also really like, as we discussed, I love working with people, so I love working with teams. I enjoy, and this is a problem that's going to require a team, right? Because none of us is going to have all of the expertise to do any of this, right? We have to bring together really creative, smart scientists together with regulators that are willing to talk to us and work with us, as well as companies that say, hey, that's the kind of problem we want to work with you on as well.
And on the opposite side, do you think there's a personality trait which kind of hinders you, or something you feel like you can do without?
Well, you might or might not be surprised to hear that I'm really a natural introvert. I'm really not an extrovert. I'm not somebody that, so for example, I once met Bill Clinton, the former US president. I once met him at an event. And it was extraordinary because, there was a group of people standing around the room, and Bill Clinton was going around the room shaking each person's hand. And there were probably, 50 people there or something. And each person he came to, when he stood in front of me and shook my hand and looked at my face, for that 30 seconds that we were talking, I felt like I was the only person on the planet. He was thinking only about me, right? He gave me that impression. And then he moved on to the next person. And furthermore, after doing that event, he was energized by it. You could see he was just, for him, this was energizing. For me to do things like that, I have to put out a lot of energy, right? It's not a natural thing for me. So I think that, these days I find that, I have to get comfortable with situations that aren't natural for me. And so that's a trait I have to work with it.
How did you then put yourself out there? You say you just require more energy, but is there anything specific you've done?
Well, I've had training from, and I've had mentors who have helped me, that's for sure. Many, too many to even name. I mean, lots of people who have been super helpful to me, my colleagues and my teachers along the way, my friends, my family, of course, my husband. Even my son is more of an extrovert than I am, believe it or not. So he often will be very helpful to me. He'll tell me, oh, Mom, come on, you can, you got this, Mom, that kind of thing. It's great. But beyond that, I would say that, I grew up in Hawaii, I mentioned that. And when I was growing up in Hawaii in the 1970s, I was a minority. I was a cultural and ethnic minority there. That might be surprising to hear, but at that time in my town, there weren't very many Caucasian people. Most people there were of Polynesian, Hawaiian, Chinese, or Japanese descent. And as a result, I looked a bit like a freak. I was taller than all the other kids in my class. I had blue eyes, I had a big nose, I had hairy arms, just believe me, I heard about this every day from kids. And it was challenging. It was really tough on me at the time, because I felt like something was wrong with me. I just didn't understand. My parents were very distracted and busy, and they, I didn't really have them to depend on. So I found I had to really dig down in myself, to figure out who was I? Was I going to be defined by other people telling me that I was a freak, or was I going to figure out who I was and what I liked to do? And so over time, I feel like I really built up this kind of, I'd call it sort of like this internal core that, I don't know how to quite describe it, but it's just almost like a safe place that I feel I can go to in my head or my heart, where I hold the things that are most sacred to me in my life. My curiosity, my respect for my family, my father, and who really supported me in many ways, and now all my colleagues, et cetera. And so when the times are tough, and I've had some very tough times, for various reasons, both personal and professional. So I don't want anyone to get the impression that I've just been, smooth sailing, everything worked perfectly, nothing ever does, right? So there've been some really hard times, and when those hard times happen, that's for me what I do. I rely on that, that core of, values that I have. And I realize that no one can take that away from me. No matter what happens, they can't. They can't take it away. I have my joy of science, no one can take that away. My joy of, my son and what we do, and, where I came from, the natural world growing up in Hawaii, those things are all sacred to me, and they help get me through the tough times.
Sounds to me that that's actually a big strength, and maybe that actually those experiences have shaped a lot of what you're doing and why you're being so successful now.
I think they've shaped me for sure, yeah.
So going back to a bit more about the discovery of CRISPR, we were wondering if there was a specific moment or whether you could share a story about when you realized quite how big or significant the implications of your discovery are.
Well, the first step was meeting Emmanuelle Charpentier. So we met at a conference in 2011 in Puerto Rico. And I remember it very well. She was sitting in a cafe, and I walked into the cafe with another colleague, and he said, "Oh, I'd like to introduce you to Emmanuelle." And her lab had recently published an important paper in the CRISPR field, so I knew her name, and it was fun to meet her in person. She was very charming, Parisian, very stylish, and I kind of just liked her immediately. And that afternoon, we walked around Old San Juan, Puerto Rico. She was remarking that it was very much like a European city. It felt European to her, cobblestone streets and little shops. And we were talking about a project that seemed like an interesting opportunity for us to work on together, because it involved studying one of the proteins in the CRISPR system, which is it's a bacterial immune system, and how it might work. And so we initiated a collaboration. So that was one moment where I had this real sense when I spoke with her that this was going to be something really, really interesting. Little hairs on the back of my neck standing up, that kind of feeling, And then I went back to the lab in Berkeley, and I spoke about this idea to Martin Yunek, who was a postdoctoral scientist in the lab at the time. And he quickly teamed up with a student, Chris Chylinski, in Emmanuelle's lab to start working on this protein, Cas9, and how it worked, what it did. And they started working together. And there was then the next moment when Martin Yunek walked into my office in Berkeley and showed me a result that he had. So he showed me data that indicated that CRISPR is a DNA scissors. It can cut DNA, and what made it really exciting is that it was programmable. And we knew how to program it. So it's programmable in a chemical fashion, and we knew how to do that based on his experimental results. And then the third moment was we figured out, based on, again, his data, how we could turn it into a technology. And that was kind of the aha light bulb moment of saying, looking at each other, I do remember that moment, and just saying, wow, the implications of this are much bigger than what we thought we were doing. We thought we were studying this little bacterial system, but in fact, it has the potential to be a powerful tool for manipulating any kind of genome.
Wow. And what was the timeline between those discoveries? Is that years?
Super short.
It
went fast. We met Emmanuelle. I met her in April of 2011. And within a year, we had published, almost a year, just a little over a year, I guess, we had published that work. So, the experiments were done relatively quickly. And by the way, this is an interesting thing. I've observed this in science, not only mine, but in other people's work as well. It's often experiments that are relatively simple that turn out to be impactful. You don't have to do, this is something important for people to understand, I think, about science. And I'm curious if you have the same feeling in your work, but because you can imagine doing very, very complicated experiments, and yeah, sometimes that you need to do that, but not always. Sometimes it's just a straightforward experiment that you do that turns out to have profound results, and that was true with CRISPR.
I think if you have a clear hypothesis that you can definitely be proving or disproving, then the experiment can be as simple as it needs to be.
Yeah.
And I guess for you, there was clearly something. Was there a time when you realized that, wow, the implications of CRISPR could be so large that maybe you could start going into places that you didn't support or didn't agree with so much? Or has that kind of evolved as the technologies evolved?
Well, I was sitting in my office in, this would have been late 2014. It was around this time of year, November or so. And I opened up a journal, a scientific journal, and there was an article in there about using CRISPR in monkey embryos. And so CRISPR had been used to change the DNA in monkey embryos, and those embryos had then been implanted into a mother monkey, who then gave birth to genome-edited monkeys. And when I read that paper, I knew that there was really no reason scientifically why this couldn't also be done in human beings. And that felt scary to me at that moment. You know, I felt scared. I feel the tension right now as I'm telling you this, because I felt it was like in the evening, it was night, it was dusk, so it was dark outside, and I just looked out the window and I thought, oh Lord, what am I going to do about this? You know, this is scary. It's going very fast, and I realize nobody in our government even knows about this right now. None of our regulators have any clue this is going on, and yet, you know, this is going 1,000 miles an hour. And so we had a meeting, we organized a little conference in the early part of the next year, that was in 2015, to bring together some scientists who could start to discuss it, you know, and figure out, what are we going to do? Is this a real risk, or am I just overreacting, or, you know? And even at the time that we had that meeting, I think there were 3 publications, they weren't publications yet, but they were, you know, academic scientific manuscripts that were in review, peer review, at scientific journals that were about human embryo editing. So I realized, holy smokes, this is going so fast, and we have to try to probably rein it in.
Did you even consider that when you first published that paper?
No, I didn't think about that immediately. You know, that wasn't my first thought, to be honest, you know, that, we have to worry about human embryo editing. It's just that it quickly became clear that that would be technically something you could do.
I guess with the field moving so fast as well, it's hard. You have to intervene quickly if you're going to be able to change it.
And I think it's fair to say that in science and technology, and we see this today with, I would say, with machine learning and AI, ChatGPT, you know, there's a certain, I think it's a human desire to push the envelope, you know, to try things. It looks like I can do this, so I'm going to do it. Maybe because it'll make me famous, or maybe because it'll make me money, or just maybe because it's cool, right? I mean, and I could see that with CRISPR as well. There would be those kinds of motivations, and it seemed dangerous to me at the time.
So do you feel like it is, I guess you took this as your responsibility, but maybe not everybody would. Do you feel like maybe if we do continue drawing parallels to AI and machine learning, that it should be the responsibility of the developers and to regulate the technology as well?
I think that's going to be tough, honestly, because I think a lot of the motivations for those developers right now, many of them are in companies, is to make money. And frankly, you could argue that to their shareholders, that's their responsibility even, right? That they should be pushing ahead to make money. On the other hand, there are dangers there. There are real risks, you know. I'm less worried about, you know, artificial general intelligence, right? I'm not too worried today, at least, about the HAL computer coming to life or something like that. But what I think is a real danger, and we see it now already, is misinformation, you know, spreading rumors or even false information widely and disseminating it in a way that people can't tell, you know, is this real or not real, or, you know, they can't tell, right? I think that's a real danger. So I suspect that it's not going to be possible to regulate it or rein it in with the developers alone. We have to involve other people. And will that happen and happen in time? I don't yet know.
So other people you mean involved into the discussion would be the public or politicians or who do you
all of the above. Yeah. So President Biden, our president in the United States, came out to California a few months ago, and he organized a small, well, wasn't he, but you know, his scientific team, they organized a small roundtable discussion on this very topic, and I got invited probably because, I don't know, because I think they could see that there could be parallels between CRISPR and this situation with artificial intelligence and machine learning. So I was part of that discussion. Biden was there, and also our governor of California, Governor Newsom. So they were both there, and then it was a group of about, I don't know, it was maybe 12 or 15 people, and I was the only biologist, but the other folks around the table were academics mostly, but there were a few people from nonprofits and from companies who were really more directly involved in the AI and ML technology. And it was very interesting because I think this was really the conclusion of that group, is that the first question is, do we need to do anything? The answer is yes. And whose responsibility is it? And it's sort of everyone's, at some level, right? And so I think the challenge for governments is how to do that. Who do you bring to the table? How do you figure out a series of steps that can be taken, and then how do you implement them, and how do you enforce them? And I think this is very much ongoing. And I think it's not unique to any one government. I think it's something that's happening around the world right now, grappling with this challenge.
And I guess these are all similar steps that were taken when you were starting to think about how CRISPR would be regulated.
For sure. Yeah, absolutely. Because I think people began to realize that, there were real risks. I mean, we didn't discuss it yet in this conversation, but, there were also environmental risks of CRISPR. Imagine that you could introduce a trait into mosquitoes, for example, that could wipe them out. Some people might say, great, I hate mosquitoes. But if you're a bat, not so good, right? I mean, there's a whole ecosystem that's dependent on insects like that. So, we have to be really thoughtful and careful. And so I think that it's just, that with CRISPR, it's an ongoing challenge that we have to continually, it's not something, it's not like a one and done thing. You have to continually be evaluating where is the technology today, because it is moving fast, where is it going, and what are the risks versus benefits of different kinds of applications of CRISPR.
And are you proud of your efforts toward what you've done towards that at the moment?
Am I proud? Well, I feel like I'm part of a whole large cohort now, right? It's not just me. And in fact, Robin Lovell-Badge, who's here in the UK, has been one of the real leaders now in that space. I think he's done a wonderful job of, organizing people. He led the conference that happened in London earlier this year on the topic of human genome editing. And we've had other people in the more agriculturally focused areas that have been, maybe a little bit less, frankly, in that area. But I think there's an awareness there as well that, we need to approach it with some caution. So I'm certainly happy that I was able to motivate people to, get involved in this. And then I had to realize that I wasn't going to have the expertise to go in all of those directions, that we really needed to get a lot of other people involved who did have that experience and expertise.
So you already mentioned that you're quite excited about a CRISPR treatment for sickle cell disease. Is there one particular current application of CRISPR where you feel particularly emotional about or particularly proud of?
I'm very excited about the possibility that CRISPR could be a preventive therapy in the future. Imagine that in the future, and we're not talking tomorrow or even in 5 years, but I'm thinking in the next decade or two, that it might be possible, I think, to provide genome editing to prevent disease. And I'll give you a very specific example. My mother died of Alzheimer's disease, and it's a devastating neurological disorder that affects many, many people around the world. And for the most part, we don't really have ways to treat it. Now, that could change, and as you know, companies are working on doing this. But imagine that you could provide people that have genes that make them susceptible to Alzheimer's, and some of those genetics are known. People that have certain types of genes are more likely to develop Alzheimer's. Imagine that you could provide them the option of changing those genes to be protective. I think that would be enormously impactful. And is that ever going to be reality? Well, like I said, it's not going to be reality in the next few years, because it's hard. You probably have to figure out how to edit cells in the brain, and enough of them, and safely enough that you'd actually want to do this. But I don't think it's beyond the realm of possibility that we could do that. And I think that's extremely interesting, and something that we're actually working on a bit at the Institute to see whether the science supports that kind of approach.
So to change track a bit completely away from science, if you were not a scientist, have you got any idea about another profession that you might want to be?
Well, I have two fantasies that I've had for my life, what I would do. One is architecture, because I'm very interested in, I like building things. I sort of as a chemist or biochemist, I like, making things and doing things in the lab. But I could also imagine doing it on a physical scale of, buildings and structures and designs. I think that's very interesting. I don't know anything about it, but I find it very interesting. And I'm always intrigued with, wonderful architecture when I travel, for example. The other is something that I just throw out there because it's kind of funny to think about, papaya farming. So, when I was growing up in Hawaii, I loved papayas when I was growing up. And, they grow very well on my native island. And I always thought, wouldn't it be kind of cool to do that, but do it with a bit of a scientist's twist, thinking about, because, one of the problems that papaya farmers have faced is various kinds of fruit flies and other kinds of organisms that attack papayas and make it very difficult for those fruits to be, transported and to have a decent market life that, you can market them very well. So the answer is right now, today, you can't really. But imagine that, you could change that. I think it might be kind of fun.
Maybe one day.
In a different lifetime, different parallel universe, I could do that.
To kind of like round this all up, is there one life lesson or one lesson you have learned in your life you'd like to pass on?
You have to be persistent. I think that's a very important thing. You have to be a little bit stubborn. I think it's maybe not too stubborn, but I think you have to be willing to, take an idea that you're passionate about that, maybe other people are skeptical. They don't think it's something worth doing, or they don't think it's possible to do. If I could, how many times in my life have people told me that's not going to be possible, or that's a stupid experiment, or that's, why are you doing this? And I've done it anyway. Because, not always, right? Sometimes they're right. I realize they're right, But sometimes I think, no, I think I'm right. And I'm going to really go for this. And then really go for it, right? Don't do it half-assed. Really go for it and take a chance. I think that's where I find that people are successful, not only for me, but I see that in people that I work with over the years as well. The ones that are really successful are willing to take a risk on an idea that they are excited about and really, really go for it.
Very good advice. Well, and I think that's all we have time for today. So thank you very much for your time. It's been a very interesting discussion.
It's a pleasure to be here. Great to talk to both of you.